everyone, welcome to Dcademy. So today we are going to continue this chapter, that is unit number 2, electrochemistry. In the previous class we have already discussed about Kohlrausch laws and discussed. So we have already discussed the topics relating to the molar conductivity, ionic conductivity, specific conductance, karino, conductors, makhalgi types, myamlo karino, Now let's see what do we mean by Kohlrausch law. Kohlrausch law is laku matamsida akoina the Bi-Hückel-Onsager rule or equation ama thamgi ko. Adugi equation da akoina molar conductivity habasiga punna limiting molar conductivity haba term ama introduce taw hokriba ko. So adugi term du kadai dagi kamaina lai and how it is related to the concentrations of the ions. Habadi kaigumba akoina electrolytes ama labu matamsida electrolyte tuna dissociation or association tawo matamda each will produce types of the ions can produce tawni hydreba. So that is two types of the ions. They are whether it may be cation or maybe anion oni hydreba. So they will have their own molar conductivity legani or masagi limiting molar conductivity legani and then makoigi masagi number of ionic concentrations legani hayaba yaiko. So adumaina legibasingdo akoina Kohlrausch law na kamay pushinggadagi habasini nasi akoina tawadarise. So let's start the Kohlrausch law sa yingsiko. So let's see what do we mean by Kohlrausch law. Si Kohlrausch law habasi sila akoina topic sa muna yingsiko. Kohlrausch law of independent migration of ions ay independent migration hindi kayo amana amada chayit nagadra. No, they will be moving independently. That means whenever there is a production of the ions, ion ama produce tawo matam sida kay tawi haba magi ion si positive ion oitaragadi positive will go their way, negative ion oiragadi negative ion will go their way ko masagi lambi du chatna gani ba. Like me amada wakan kanba matamda dilemma haba pot ama takramani ko tariba dilemma haba pot se karino hay taragadi wakan se am chamam na ba like aina wakan ama khalikan sida as adugu phagadrani anum khanba ko adigi phakte hay taraga so atu dum phani da anum khanba natragana aina tawiba pot se phai khangna kedoba mi atopa aigi nage ta lariba natragana society da lariba mayam sina aigi maranda kai khandini aina sumai taw khadi moina kamai lakpa adi ai sumai taw taragada ahem future da kamai tawrakpa aigi present sida sumai taw taragada ai huji ki di pharani hayeng namu kamai tawba sumaina dilemma wakan maphang khanba natraga afabasu phatabasu animatu yemba kanda thabak se amta tawba ngamdabado adugi case to natti habisidati right ko. So in this Kohlrausch law there will be the migration of the ions mapham amadagi amada chakaniba. That means whenever there is the flow of the current there will be the flow of the electrons hydra. So these electrons possess which type of ion? Ion makhalam possess tawe kay hai electrons hydra say it is negatively charged. That means makoy se anion ge character chele haiba yaiko. So in this case independent migration of ions have a matham seda. For the electrolytes there will be two types of the ions and these two types of the ions will be of the nature that is positive charge and the negative charge yarani ko positive charge and negative charge legani. So what this Kohlrausch law states to us have a pot samging as a kai haini ginomana. Let's see here. It states that the limiting molar conductivity have a tamamuthuleko. So in the previous slide we have already known that according to the Bi-Hückel-Onsager equation this molar conductivity is given by limiting molar conductivity minus A, that is a constant, and root over concentration. Concentration ki term sida half over power se root over ni ko. So here sida gi akoina limiting molar conductivity have term se introduce to how given ne bas minus amma lay kana introduce to bodo ko. So sida high it states that kanano na it hay se Kohlrausch law na state tawe kay hay na limiting molar conductivity kanani of an electrolyte can be represented as the sum of the individual kanano individual hay sa contributions of anions and cations. Contribution haraga sida s hay sa this is a mistake type of mistake ni ko. Okay sida hay kaya na Kohlrausch law hay taragadi it states that the limiting molar conductivity of the electrolyte. Electrolyte amagi limiting molar conductivity habasi karina pigani haba matamda whole electrolyte tugi masagi ionic concentration term tugi total samduna pigani haiba. Naiko. That means the sum of the individual contribution of anions and cations of the electrolyte. Whenever there is the electrolyte, for example, let's take copper sulfate or maybe zinc sulfate or CI. See, mamanga classes to see examples. We can also take silver nitrate. Copper sulfate lower boundary, zinc sulfate lower boundary high target, we can also take a silver nitrate lower seba. Silver nitrate lower matam it will dissociate into two types of the ions. Silver nitrate is also a type of the electrolyte, copper sulfate and zinc sulfate is also a type of the electrolyte. Electrolyte ni high target, whenever there is the flow of the current pass the matam it will get dissociated into two types of the ions. Ion kan ani thokrani, ion kan ani se kana silver cation, nitrate, and ion. Silver cation, nitrate, and ion. That means silver will possess positive charge and nitrate has negative charge. So, electrolyte amana dissociate tawbo matamsida ion ani thokle kana cation and anion. Chumiko adu eragadi karigumba akoina electric current se thado tapita thamme ko thajindabida tumina thamma matamsida so legadoreba the amount of the concentration is what sigi potsak sineba positive ion ga negative ion ga magi total amount neba chumiko adu eragadi Kohlrausch na hairisi lanpham thokra thoktre chumiko. The limiting molar conductivity of an electrolyte is represented as the sum of the individual contribution ions. Individual the kana positive ion habamaga, negative ion habamaga, and it will like sigumba ion sing sigi masagi contribution do electrolyte da aduna lepkani have. So there is a representation. Limiting molar conductivity say capital lambda not na denote to matam sida V plus and lambda plus not will denote the positive ion gi organi have. Negative layer negative ion, that means anion gi organi have. So the V plus have a V minus high report say kana organi have matam the number of the cations and number of the anions organi and lambda plus naught and lambda minus naught had a napagal yariba limiting molar conductivities of the cations and anions respectively. According to the Kohlrausch law, we come to know that the limiting molar conductivity of an electrolyte is given by the total sum. So the plus sign middle chumiko. So that means the total sum of the individual contribution of anions and cations. Chumiko. Kohlrausch law na limiting molar conductivity have a karino have a matamda limiting molar conductivities of the individual mayamdugi samdo electrolyte amagi adu koina molar limiting conductivity kogani have. Yaraba. Now let's come to the next slide. Note ni siko Kohlrausch law na hagibudugi matung hina hojik laktani. For weak electrolytes, karamba weak electrolytes. Aina mamang class ta high grade kaina. Electrolytes there will be mainly two types of the electrolytes. Karana strong electrolytes, karana weak electrolytes. Strong electrolytes kangu sina kaidogada ba example da HCl gumba han high grade ba. HCl gumba se ba they are strong electrolytes. What about the weak electrolytes? Weak electrolytes kung high target di akoni acid magta high target so acetic acid or vinegar chumiko. Acetic acid natraga vinegar gumase kay ba they are weak electrolytes. So for the weak electrolytes, the molar conductivity, limiting molar conductivity high de ko. Molar conductivity delta M have increases steeply on dilution. ꯑꯩꯈꯣꯏꯅ ꯃꯃꯥꯡꯗ ꯀꯩ ꯍꯥꯏ ꯃꯃꯥꯡꯒꯤ molar conductivity ꯅꯩꯅꯕ ꯃꯇꯝꯗꯨꯗ ꯀꯔꯤꯒꯨꯝꯕ ꯑꯩꯈꯣꯏꯅ strong electrolyte ꯂꯧꯔꯒꯗꯤ ꯍꯥꯏꯀꯣ strong electrolyte ꯂꯧꯔꯒꯗꯤ molar conductivity ꯁꯦ it will slowly increase on dilution ꯍꯥꯏꯅ ꯍꯥꯏꯈ꯭ꯔꯦꯕ ꯆꯨꯝꯃꯤꯀꯣ so in the case of the weak electrolytes ꯒꯤ ꯑꯣꯏꯅꯗꯤ ꯃꯥ ꯃꯁꯥꯁꯦ diluted ꯑꯣꯏꯕꯒꯤ ꯃꯑꯣꯡꯗ ꯂꯩꯔꯤꯅꯦꯕ concentration ꯋꯥꯡꯗꯦꯕ ꯃꯥꯗꯤ ꯀꯣ so for the weak electrolytes the molar conductivity increases steeply increase tawwe haise slowly increase tawna kanada on dilution for the strong electrolytes but for the weak electrolytes the molar conductivity increases steeply on dilution madi sa increase tawgrani ba that is with the lowering of the concentration se masagi hanagi handhara ledingai duda amukka hena dilution tawhallagadi it will increase steeply yang mathak to hector for example let's say here it is a plotting has equal plotting the increase of is fine increase of graniva but for the case of the strong electrolytes on alarm taragadi it will increase slowly in this way linear the oitar was slowly increase the graniva but for the weak electrolytes going to steeply satlawna yang nakakhakhini haba ko and at infinite dilution higher dilution se kitang tawba horko matam sida weak electrolytes se kidogani high mass steeply increase tawgrani higher limiting magi molar conductivity se ko but at infinite dilution se sum yam hena tawkhana agadi have pot amalai ko so in this case concentration se kai da jakrani it will tends to be zero concentration se negligible or rani ba zero rom the laksalani and alpha high what do you mean by alpha here alpha high report say it is dissociation degree or degree of dissociation degree of dissociation degree of dissociation so this alpha degree of dissociation say 1 ga manarakani hai karam kanda when this concentration terms tends to be zero then the degree of association or dissociation say report say alpha say it may be degree of dissociation or association or for this we are considering degree of dissociation ni hana lawraseba because electrolytes kai da kaithani hai ions da kaithani hai kaithaba means dissociation chumiko adoredi kai hani alpha se 1 ga manarani kai hai no sa that is the electrolyte dissociates completely koine kai hai electrolytes ang malawu matam sida example AgNO3 amana positive ion oigini amana negative ion oigini ko adu oiragadi c concentration siga c concentration siga number of ion concentration chap manaragadi kadabu ya the division between these two will give 1 right 1 p durabanina koina degree of dissociation or degree of association se kai gamanani 1 gamanani hena laweb at infinite dilution da yare ko so at infinite dilution c tends to 0 that means concentration will tends to be 0 and the degree of dissociation will tends to be 1 rani ko sin haning si kai no dissociation have a process fully and completely happen that we have that means the dissociation occurs completely in this type of the dilution infinite dilution da then alpha have a process kaina lepkani haba alpha is calculated with the relation or the ratio between molar conductivity and limiting molar conductivity okay now question number yengsi ko icham question ni kai hani yengsi why does the conductivity of a solution decreases with dilution kai hai no conductivity of a solution say decreased away on what dilution yare ko kai it is because conductivity depends on the number of ions number of ions yare ko so degree of dissociation hana panba matam sida ion se chap manana kai thagi number my value se 1 orine ko ajan sidagi kai khamanga me khoina conductivity of a solution say decrease the Karam kanda dilution da. Maram karigino haragadi kariguma dilution tawgragadi the concentration of the ions also decreases. Concentration of the ions decrease tawgragadi kedorabtoiba the number of the ions will also decrease. And for the ionic conductivity onadi number of ions increase tawrigai the conductivity will also increase habaneba. Aduna sida kaigumba sigi conductivity have term se it may be very sharp to the conductivity makhan lay factors term tongan PPI ko. For here sigi onadi akhona hojik lawi se it is ionic ni ko. Ionic conductivity ionic conductivity. So ionic conductivity ko onadi magi ion concentrations handagragadi kadawni ba decrease to wini have ionic conductivity se. So here present in the solution number of ions present in the solution that depend on na conductivity se handagrani and with dilution it decreases and hence the conductivity of the solution also decreases. Dilution the over concentrations in them aduna magi concentration nemta bhaise kaina conductivity da handagani have. It is a concept based question ko. So minor questions se macha nei na bu yai ko. Like ionic conductivity ko na factors myam na giba mathamda kaiguma temperature increase to kai ni have ko se. With the decrease of the temperature ionic conductivity will increase so maya ko. The increase of tar di kedawni kamaina no increase decrease la is sida aina suma hare alpha have a degree of dissociation ni hare ko. Degree of dissociation se kanaga proportional oi hai duna it is directly proportional with the molar conductivity ko. But it is inversely proportional with kana limiting molar conductivity. Limiting molar conductivity is in hand target it will never equal to 1 ka kidunga manara. And if molar conductivity shina helam taragadi ko with the increase of the molar conductivity the degree of dissociation will also get increased na company have. Now let's go to the next slide. So sidana akoina Kohlrausch law do khangrabani na mase kadai de apply tawgadagi kai kai sijinai habadani ko yengdo sha. So let's say here application of Kohlrausch law. Application of Kohlrausch law da akoina kai decision ne ba first thing we have come across was limiting molar conductivity hypothesis ne ba aduna akoina decision ado se to calculate limiting molar conductivity for any electrolyte. Apiba electrolyte ama hekta samna harabada akhoi da HCl pi ha se electrolyte se khamdre ma ki limiting molar conductivity se adu calculate tabu madamda we are going to use the Kohlrausch law. Then from lambda naught macha ama pi ko this lambda naught is the ion gi limiting molar conductivity so we have come across like this limiting molar conductivity capital lambda gi pot se kedaweba is equal to V plus lambda plus naught plus V minus lambda minus naught. Adudi sida yauriba lambda hariba pot se naught matak 0 manba mata pise degree manba mata pise ko it denotes limiting molar conductivity for kana cation and anion. Galani ko aduna masa ke individual ions to gi limiting molar conductivity khangaba matungda limiting molar conductivity whole electrolyte to gi puthokpa yarani ha. Then in point number 2 for the electrolytes like karamba weak electrolytes like acetic acid that means CH3COOH ko sigi acetic acid sigi oiramaga suka dawdeba dissociation constant can also be calculated akoina mamana kai khangi dissociation constant or degree of dissociation hai ko degree of dissociation or dissociation constant alpha hypopoto puthokpa yai hedra that means on dilution or on infinite dilution C tends to 0 and alpha is equal to 1 hanlaido adugi poto laibanina we can also calculate the degree of dissociation or dissociation constant so puthokpa yagani haba. Now let's see the note ta kai haige yingsi ko electrolytes are substances electrolytes have zikarino habadani so hana de chin habani hojina mu yengase electrolytes have zikarino ko electrolytes are substances that dissociate in the solution amada dissociate tawdiba kaithagani habuko to produce kana produce tonava ions produce tonava. What types of ions? It will produce two types of the ions, that is cations and anions, and hence conducts by high electricity in dissolved state or molten state. They have a dissolved state that natragana molten state that mass electricity conductor wunga me tumiko. That means for every type of the solution which produces the ions, that may be the positive ion and the negative ion, it will be able to conduct the electricity in the molten state or in the aqueous state or the dissolved state. Aduna electrolyte have a process of karamba posakni hagani akoina. They are conductors. Karamba makhalki conductor, they are electrolytic conductor. Now it has two types. Kana. It has two types. Weak electrolytes, strong electrolytes. What are the weak electrolytes? Weak electrolytes hai taragedi carbonic acid. Karamba type of acid no kadai yawi carbonic acid se kono soda drinks kumbada. Nushit kam thorakpada yariba acid to ko soda drinks kumda yariba acid se ayodeba it is carbonic acid. And then acetic acid, vinegar the happy acid se it is acetic acid. Next hydrocyanide and etc. Then strong electrolytes da here go HCl high ko inu mamang da HCl is also what? Strong electrolytes. NaCl sodium chloride hydrogen it is a strong electrolytes because it gets associated into Na plus and Cl minus. Directly dissociate the we are fully completely dissociate the we are they are strong electrolytes. And then sodium hydroxide. Sodium hydroxide it is a strong base and it is also a strong electrolyte. A strong base so a strong electrolyte. So, and you might have seen this HCl. HCl have a strong acid as well as strong electrolyte. So these are all details about the electrolytes. The electrolytes have conductors and maybe known as electrolytic conductors. It may have two types. There are weak electrolytes and strong electrolytes. Their examples are weak electrolytes, carbonic acid, acetic acid, etc. And strong electrolytes, HCl, sodium chloride, and sodium hydroxide. Okay. Now let's come to the next slide here. Now the most important part of this chapter is the electrolytic cell. So from the very beginning, we have come across the topic that is electrochemistry, and this electrochemistry consists of what? The electrochemical cell. Electrochemical cell have electrolysis or the electro battery natraga cell manen hydra aduda kai thoon oxidation amasung reduction je thoon neba taraba kanana samnani hai salt richness samnani hai. But now what do we mean by electrolysis? Electrolysis and electrolytic cell have never. So electrolysis or electrolytic cell have is sukam khang tine mamang da mamin si padam pan mama terms te kai khange. Electrolysis mamin se terms hana khaido kisi ko sida. Electro have the electricity, lysis have the breaking neba yaraba. Doiti electric matek na kariguma compound ama natraga electrolyte ama bu kai thahalaba kari form da smaller ionic form da adu edi kai kauni ba. It is known as the electrolysis process to be maming share electrolysis ka wani hab yare ko. And what about the electrolytic cell? Electrolytic cell edi kaino we have come across the electrochemical cell hana logreba. Electrochemical cells hi kai lowi koina we take the two half cells lodra karamba aman oxidation half cell aman reduction half cell. So oxidation half cell and the reduction half cell is connected by the salt bridge. And these two cells is connected with what? Electricity. That is battery ka connect roga thamjana koina adu maktubu adu gi system whole apparatus to adu koina kai kaudaba that is known as the electrolytic cell. Akoina electrolytic cell amalo matam se we can also take example for this Nernst cell or Galvanic cells low we aibo ko kai gi no have matam da. Whenever we take the electrolytic cell, it will consist of electrode, electrolyte, and electricity. Main thing ahum ni ko magi kana electrolyte, electrodes, electricity. Yari ko kay digi loila electricity have a possible And last one is the electrons. There are four components. Four components na kana-kanano. The first one is electricity. Next is electrolytes. Third one is electrons. And another one is electrodes. So, for these electrolytic cells, we have four components. First is electrolytes. Electrolytes. For the second one, it is electricity. Electricity. For the third one, it has to be the electrons. Electrons. And last one is the electrodes. Electrolytic cell main thing electrolysis electricity. That means electricity then electrolytes electrons electrodes electrodes electron flow electricity current 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 na maram oraga electrons ki magi micais ona tainana opposite chakani kana hagibedo adu loi thoktoini ko kanana no thoali nyam se the main source electricity na thonani haba. So basic concept is electrolysis have a posi electrolytic cell da thogan gadabani kanagi mateng na electric mateng tare ko. Now let's see here. The electrolytic cell consists of an external source of voltage. External source of voltage has electricity ki supply se ko battery dagi samakani haba to bring about a chemical change. Reaction. Then electrolysis ki definition is electrolysis may be defined as the process of decomposition. Decomposition is a bigger molecule will be breaking down into the simpler, smaller molecule or ions of an electrolyte when an electric current is passed through it, either in the aqueous solution or molten or a fused state. Aqueous solution na molten state or fused state. So let's see here. See figure electrolytic cell one is anode, cathode. They are fourth one electrons. Then this one is the Roman number 2 electricity. Then electrolytic density, it is a vessel. Then here fuse or dissolve electrolytes. Solutions. These are electrolytes, Roman number 1. And this one, negative charge, positive charge, these are all about the electrons. Current 2000 electrons. It will go into this side and not from the electrons flow. So electrolytic cell will consist of 4 main components. They are electrolytes, electrodes, electrons, and electricity. Now let's see here. Electrolysis have a karigumba law ani khakna govern tawi ko mase sumaina chatnagadabani hanhai ko adugi law dugi maming na Faraday law ko. It has 2 types of the laws. First Faraday law, first law of electrolysis natragana first Faraday law ko second law of electrolysis or second Faraday law hana khangne. So yengase kai haiba quantitative aspect ni ko si se quantitative aspect of the electrolysis hai bochi concept macham khangni kamaina no yengse ko quantitative hai target it is used in the calculation to matam measure to matam decision adoini ko. Now here Faraday's law of electrolysis hai Faraday haiba pasina ko scientist na kedarameba puthuomba law ni ko aduna mana puthuomba electrolysis ki law se karam matam na puthai ji mana. After his extensive investigation, experiments mayam taraga yamna khanaraba nainaraba phasana nainaraba matungda mana electrolysis ki solution si matangda males ki matangda males having a fused state or molten state adugi matangda phasana nainare. Then he published kay publish tawe mana magi results singse 1833 dagina 34 hawda kay gumokon research ma taw taragadi ko paper publication na taw bachane ko adumaina mana se research myam se tawre kanada research tawi mana electricity or the electrolysis of the solution and a melt have topic sida study present tawre investigation ta thare phasana taw thare ko aduga nei ya ko nei de matungda mana publish tawe magi result myam se 1833 and 34 sida ko 1833 and 34 sida mana publish tawraba matungda in the form of the following laws mana publish tawriba pot se kaidano chatnaba yaba mayamda aina si is sagatlabani hana ko de bithorako se gift oina bithore se law gi form da bithoreba karam law no hainagadi first law of Faraday or first law of electrolysis and second law of electrolysis law ani kha ko da gift oina piyaba ko ko da kudol tami ha now let's see what does this first law of Faraday or the first law of electrolysis says to us. See, first law of Faraday is in high. It states that the mass of substance deposited or liberated at any electrodes is directly proportional to Canada quantity of charge pass. Kon electricity and high ko electrolytic cell amada electricity yawgani high. Sagalakwa matam sida electricity pass to bugi chang to chap manana it will be directly proportional with what the mass of the substances deposited or liberated. Mass of the substances, for example, akoin hana anga oi kandi kai khangi kai gumba electrolysis thogadi anode mud and high. Chumikwa natragana metal amadi deposit tawni hen high adugi depositor riba metal do adugi mass se kanaga manani ba the charge or the current pass adugu manani haba man so he derived the relationship as W is directly proportional to Q where W have a kai oduna it is the mass or the weight of the substance neba yaraba metal dugi weight aduga directly proportional to kana Q that is charge to go directly proportional oi high Q sidi kai gamane haba Q equal to IT that means charge is equal to current into time ani sigi multiplication of mane high grade aduna hoji Q gi value se mohapchan mamutamna kai oire W is directly proportional to I and T and then W have a sigi proportionality sign se lakhogna bagi da mutakuna Z have a ponam happen Z is what the electrochemical equivalent constant constant ko masa and then now if kaiguma current sina 1 ampere oiramaba ko times 1 second oiram targadi kanaga manarani W is equal to Z that means mass of the substances will be equal to the electrochemical equivalent ko manarani ba ko adu idi kai haidoba hence the electrochemical equivalent is defined as what the mass of a substance deposited by passing 1 coulomb of charge or 1 ampere of current in 1 second 1 ampere of charge 1 ampere of current pass tauba natragana 1 coulomb of charge se pass tauba matam sida hangadariba mass of the substance to or the mass of the metal do adubu khone electrochemical equivalent ni hana define tawgani haba so this is the first law of Faraday ne kai hare targadi the mass of a substance is directly proportional to the charge pass now let's come to the next second law second law na mo kai haini it states that the amount of the different substances liberated by the same quantity of electricity passing through the electrolytic solutions are proportional to their chemical weights. In the first case, first law the high luna kahaba any substance sama deposit tawgira najaga liberate tawgira electrolyte to dagi ko electrolytic cell do dagi kaigumba mass ama or substance ama ki mass ama liberate tawri high target ito gi mass to charge to be flow duga or charge pass to duga value chamana ni havna that is proportional ni havni buka adubu second law na kai haraba ma second law na high it states that the amount of the different substances amount of the different substances liberated. Different substances has whenever there is an electrolyte oitaragadi substance anidi compulsory thorkaniba. One will be the positive, one will be the negative. Electrolyte se chap manana sizinnabasu yawi, manadana sizinnabasu yawi. Aduna tungan ba substances liberate tawrakpa matamda by the same quantity of electricity. When electricity pass tawusile chap manana pass tawre haiseba ko 1 coulomb pass tawre ko adu taragadi adugi matamduda electrolytic solution do the pass tawre aduga phangiba potse kana proportional ani haba proportional to their chemical weight kamana gani ham. For example, aina chlorine je pass tawre ni haiseba ko adu taradi chlorine je kai oidoba it will be 35.5 to dum organiba natragana sodium se thazalini hai targadi sodium ki 23 do dum organi haba yare ko. Now here atomic mass of metal divided by number of electrons required to reduce the cation. Cation gini ko sina aduga metal du kumana gani haba. Means anion high target non-metal. Natragana kay oidoba it will be the negative ion oidini dina. Is the metal gina cation la gani haba. Yari ko. So here the atomic mass of metal divided by number of electrons required to reduce the cation is equal to equivalent mass of element or the metal divided by equivalent mass of another metal or element ko mana neba. Then magi po che kay gumba khoina mathakta leise A deposited hai ko makhada leise na B deposited. That means mass of A deposited divided by mass of B deposited will be equal to equivalent mass of A and equivalent mass of B. Mass A giduna equivalent mass of A ga mana ni haba. Mass B duna equivalent mass of B ga mana ni haba. Yare ko. Now note the charge on 1 mole of electrons. The charge on 1 mole of electrons is normally taken as kay ga mana ba 1 Faraday. Faraday constant ga mana gani haba. 1 Faraday se kya no 96500 coulomb per mole ga mana gani haba, which is also called as 1 Faraday. 1 Faraday of charge kumana gani aduna kigumba khoina 1 Faraday of charge kana kamana ni haradi it will have the value of 96500 coulomb per mole kumana gani hare ko. Now products of electrolysis kaigumba electrolysis thokre adoi target electrolysis to lower matungda kaidorakadege kai tholakani. It is the type of the reaction ni have natra reaction ni karamba type of reaction. It is a type of the decomposition reaction. Yare ko decomposition ni kaino composition thugai do ni kahin do ni hana leramba composition do gi ma chauba ma leram targadi ani thon do ni ba yare ba. Then what will be or what is the product of electrolysis hai targadi na sa A B and thole potsing ni ba ko. Let's see. The electrode is inert. Inert hai kaino they are non-reactive. Reactive oidi hai ne ba yar ba. So the electrode is inert oirama ba if have ni ko if the electrode is inert non-reactive then it does not participate in the reaction. Kay gumba electrode se inert oi hai targadi reaction da yawningdre ba ma se tuminna yunga lagi dun ba. That means tuminna reaction na nakana ma thoba so it will not participate in the reaction. Reaction da yawra roi do ne ba mangala ki bido. For example mi hole amada pulap ka silanga ga tuminna ga le thokodo adumana lagi tane ba nare ko magi manaksi da brom ising asaw ma am tham tare ga sumai ga jaga. For example let's say like muni amana dhyan tawu matam sida magi akoi bada yamna langa ka so madu dhyan adum toraga leine bu honai dana aduguma bol oidene ba inert hai report yare ko. So sumaina leiragadi kai gomba electrode amana inert oiragadi kai haba ma sa it does not participate in the reaction to the yaudre ko aduna ka dokani and X only as a source kai hai tu ba X only as a source or sink for electrons myam sigi chatnabagi lambi natragana electron thoroknabagi lambi oina lehini haba man yare ko. Reaction to the yaudra so mana gyan laksing myam amadi pi dro khoda pi ko asai gi muni amana mana dhyan phasana tawrani atop mayam sidagi kaimta changarwa khando adoi taraga su magi masagi oiba dhyan du loira matung du knowledge mo thor ko do ko pithok na bu honadro adumaina it will be acting as a source of electrons natragana sink of electrons when act wini haba yadeko then point number 2 the hashna if the electrode is reactive electrode say am reactive oraba adu edagadi it participates in the electrode reaction electrode reaction haba matam seda it may be oxidation or reduction ko adu nga sa hagire matakta electrode say inert oiragadi it does not participate in the reaction reaction they participate tawde adubu it acts as a source of electron mangona ge electron bithok pina tra source hai tare le dia adu adi there will happen oxidation yare ko inert oiba electrode to the oxidation chathagani haba and what about this electrode which is reactive reactive oriba electrode se sidana electrode reaction yawi haina tra that means reduction ko reduction yan taradra sida hainingisi karigumba electrode amana inert oiragadi yariba makai mangonda kai thona bana tiba oxidation ko aduga reactive oiba electrode ni ha kadi mangonda reduction chathana bu khonrakani ha heraba now note isi ko during the electrolysis of sulfuric acid ki formula ningsing si ko authopa yade H2SO4 so sulfuric acid se electrolysis tawum matam sida following processes occurs haraga yaudre okay let's say sulfuric acid haba pot se C ki pot se thugai rak toi ne ba yeng si ko so here si electrode thamgre ko sidana H2SO4 yarba then sidasu zinc sulfate hape hai si ko adu iregadi si hydrogen siga si sulfate siga si zinc siga si sulfate siga tongan na chalak se mane hydrogen se dissociate tawre so for example si sulfuric acid si pull up se dissociate tawe haragadi it will be like H plus SO4 2 minus malakani ko negisi pot se na mo Zn2 plus SO4 2 minus sumala tudan tra sumana dissociate tawuduni haba so here sida kaila a positive ion sida kaila a negative ion chamana na sida su positive ion negative ion na chakani haba yaraba so during the electrolysis of the sulfuric acid also the following processes occurs sigma processing je thokani haba reduction oxidation thokani hydrogen se reduce tawhanbagi reaction su lakani ko aduga ion on bagi su lakani hab yarani ko okay so in the next class we are going to continue about the battery this will be the last topic of this chapter battery gi part ma lushinduni ko so battery haba sida koina primary secondary and tertiary order of fuel cell hab si laktuni ba aduna primary cell na kana kana yawani secondary cell na kana bu khamnai fuel cells na karino ka economies na hydrogen fuel ni se economic fuel ni kana hai se kari gino haba adu shimna na aduni so to the next class please be safe like phasana pasi ko adu ka mamang hai griba electrolysis ki reaction so amuk hanan ne si so in the next class we will recap with the full details what we have done in this class till then bye bye